And hope you all are fine. This is epidemic time, so stay at home and stay safe. I'm Dr. Suman, working as an assistant professor in the Department of Physics of IHL or BPSMB, here to teach you the physics of BSc course. As everyone know that as like in first semester there are two papers, or in all the BSc course there are two papers of physics. First paper is our properties of matter and kinetic theory of gases, and second paper is semiconductor devices, which is I'm going to teach here. So in semiconductor devices there are four units. First unit is semiconductors, second is transistors, and third is transistor amplifiers, and last is oscillators. This is a step-by-step procedure. In first unit we study the how to differentiate the different materials, and by which material we use the formation of junctions and different diodes, and with the help of the junctions and diodes we will form the transistors. And after making the transistor, fabrication of transistor, we will use the in transistor amplifiers, and these transistor amplifier in used in various applications like oscillators. This is all about syllabus. And the semiconductors completely revolutionize our life, or this modern life. Why? Because in every situation, like in our mobile phones, laptops, our computers, everything is in computer control, or we can say that this is the age of computer. And how we can say that this is the age of computer? Because without computerizing anything, we can't follow anything. Like our Aadhaar card is also linked with some account numbers. In this way, everything is connected to the computer. So this is the age of computer. And in computers, we are using semiconductors. In your home also, you are using washing machines, excising machines, everything have digital display. So in these machines we also use the semiconductor materials. And last year ISRO set the Chandrayaan, and in Chandrayaan there is also the use of semiconductors. Many things like solar panels, or many medical instruments, there is lots of use of semiconductor materials. That's why the semiconductor materials are very important, and which is going to study in our lectures. First, the semiconductors. Why the semiconductor is so important? Basically, we study the one basic property, that is electrical conductivity. What is electrical conductivity? Electrical conductivity means the ability of any material to conduct the electric current. Conduct the electric current means we have lots of material, like first is silver, which having the electrical conductivity 6.3 into 10 to power 7 Siemens per meter. This is the unit of electrical conductivity. We have electrical conductivity is the ability of any material to conduct electric current. Okay, and unit of this electrical conductivity is Siemens meter. And we have different materials like metals, semiconductors or insulators, silver, and same in this way, copper having 5.88 into 10 to power 7 centimeter Siemens inverse. And then there are various materials which having conductivity in this range. Next is our silicon having electrical conductivity 1.5 into 10 to power minus 4 Siemens meter. And then germanium. Why we are discussing? Because why the semiconductors are so much important, we are studying this. And here this is 2.51 Siemens per meter. And then there are many semiconductor lie in this category. After that, this is glass, which is insulator, and then rubber These have the electrical conductivity 1.5 into 10 to power minus 11 Siemens per meter, and the rubber having 1 into 10 to power minus 16 meter. As you see in the series, that these are the metals, these are the semiconductor, and these are the insulators. Why these are the metals? Metal as the conductors, these are the conductors, and these are semiconductors, and these are insulators. Okay. We can differentiate semiconductors, and insulators on the basis of this. They have high conductivity of the order of 10 to power 7. They have conductivity of the order of -4 Siemens per inverse, and insulator having very low electrical conductivity. And with the help of conductivity, we can show that the conductors, the materials or the metals which having high conductivity are known as conductors, and which having very low conductivity are insulators, and the material which lying in between these conductors and insulators are semiconductors. One another basic difference is what the electrical conductivity means to conduct the electric current, or where the electric current come from, that is the movement of electron. So we will study how the electrons movement is different in all these three categories. We will see the movement of electron in all these three categories. And movement of electron means the matter is made up of atoms, and atom consists of electrons, and in the nucleus nucleons, and this idea of atomic structure is finally given by Bohr's. Before Bohr's model, various scientists like Dalton, J.J. Thomson, Rutherford, they give the various factors about the nuclear model or atomic model, but the Bohr model will be accepted by various scientists. So what is the Bohr model? Bohr model say that the central part is nucleus. This is our nucleus, and what is this nucleus consist of? This consists of nucleons. And what are the nucleons? Nucleons are the protons and neutrons. Protons are the positively charged particles, and neutrons are neutral particles. I think everyone of you are aware of this. These are the positive charged particles, these are neutral particles. So all the charge of nucleus is positive, and in outer part these are the orbitals. In orbitals, electrons are moving, and basically the movement of these electrons will responsible for the current. And how this movement of electron will be followed by different elements, and or the electrons of one metal or one material is different from other materials. No, electrons for every material is same. Basic the distribution of electron, how the electrons will be distributed in their shell. So we discuss the little bit of distributions of electron in their different cells of the elements. And this distribution is given by Pauli exclusion principle. Pauli exclusion principle is that no one electron should have the same, this is the configuration. What I am saying, that Pauli exclusion principle. Pauli exclusion principle says that the electron with same spin can occupy only one state, and in one state we can see that two electrons are occupy, one with upper spin, one and down spin. Or this is broadly you can study in quantum mechanics. I am not discuss broadly the Pauli exclusion principle. I am only saying that how the levels becomes bands in case of solids. When we discuss the atoms, there are the series of energy levels, but when we come across the solids, or when the atoms join together to form the solid, then what happened to the energy levels? This is the energy level diagram. Here this is the energy levels, and in this side we put the number of atoms. Suppose here is one atom, or one atom means suppose we have sodium, and what is the atomic number of sodium? That is 11. And what is the configuration of sodium is, we can put like this: 1s2, 2s2, 2p6 and 3s1. These are the number of energy levels. Means this is the energy where the two electrons spin with up spin, one with down spin. This is the another energy level, that is 2s2. This is 1s2, and again this consists of two electrons, one spin, one down, one up. And next, this is the level 2p6. This consists of 6 electrons, one up, one down, one up, one down, and one up, one down. 6 electrons, 3 electrons with up spin, 3 electrons with down spin. And next level is your 3s1 level. 3s1 means this level has an occupancy, और इसके अंदर कितनी occupancy है? S में 2 होने चाहिए, but यहाँ पर 1 है, तो यहाँ पर 1 है. This state remain to be unfilled, means this have only occupy the 2 electron, but here is only 1. Same if we take the another atom, this is also same configuration. यहाँ पर हम एक atom ले रहे थे, यहाँ पर हम 2 atoms लेते हैं. तो same state, the energy level should be remain same, but the energy levels are 2. This is only for differentiation. I am showing 2, but the 2 levels are on the same energy grounds, or same. In this way 2, and in this way 2. Next 3. So we can take the 3 levels, and 3 levels, and 3 levels. Okay. But the solids is not composed of 1, 2, and 3 atoms approximately, or we can take 6.029 into 10 to power 23 atoms per centimeter. This is the approximate idea. So if we take 10 to power 23 atoms together to form the solids, then what happened to the energy level? The energy levels are so close to each other. These are the energy levels. Same. These are the energy levels. Means the energy levels we can't see as a discrete number. We can't see the discrete number as like in case of single atom, double atom, or triple atom. So in case of solids, these lines will be form a bands. These are the bands. These bands is known as energy bands of solids. In this way we can show that how the bands are formed from the discrete levels. Or here is one term is calculate that the energy bands. From these band again we can find out the term valence band and conduction band. Which one is the valence band? Which one is the conduction band? The filled band. Here is, in case of sodium, this is filled, this is completely filled, this is completely filled, and this is not completely filled. In case of sodium or any other atom, the highest filled अगर हम if we take from the ground to highest, which one is highest filled? This state is highest filled. So highest filled level which is completely filled, highest energy level which is completely filled, this is known as valence band. और यहाँ पर अगर हम किसी और एटम के लिए जाएं तो एनर्जी लेवल्स तो ऊपर भी हैं, बैंड्स ऊपर भी बन रहे हैं, लेकिन ऊपर की तरफ से अगर नीचे आते हैं तो यहाँ पर क्या होगा? ऊपर completely empty, but this is not completely empty. So the lowest band which is not completely filled, that band is known as conduction band. I think I cleared the valence band and conduction bands. Once again, from the lower side, if we see that the highest energy level which is completely filled, known as valence band, and from the upper side we can see that the lowest band which is not filled completely, that is conduction band. And the difference between this valence band and conduction band is known as band gap. And band gap is denoted by Eg, and this Eg is also measured in electron volt. So the other term by which we can differentiate the conductors, semiconductor and insulator, that is band gap. In case of conductors, the gap between the conduction band and valence band is no more. कोई भी अगर गैप नहीं होता तो हम उनको बोलते हैं कंडक्टर्स. मीन्स देयर इज ओवरलैपिंग ऑफ. दिस इज अगेन द डायग्राम. इन केस ऑफ कंडक्टर, दीज आर द कंडक्टर्स, दीज आर सेमीकंडक्टर्स, and here is insulator. This is valence band, this is conduction band. Valence band, conduction band. There is no energy gap in case of these two bands. Or in other term, if I want to clear that, in case of conductors, there is a space for electrons which is freely moved, or we apply an extra energy to the conductors, then the electrons more conductivity will be produced by the electrons. So these are known as conductors. But in case of insulators, this gap is very large. This is valence and this is conduction. This band gap is greater than 5 electron volt. Means there is no conduction of electric current, there is no current or there is no movement of electron in case of insulators. But in case of semiconductors, there is some gap which is approximately equal to 1 electron volt. This is valence, this is again conduction, and this gap is approximately equal to 1 electron volt. Means here the electrons, we take the extra energy, they jump to the valence conduction band and they are freely moved and produce the current. So the semiconductors at room temperature or more temperature behave like as conductors, but at low temperatures and when we are not providing any energy, then this semiconductor act as insulators. So this is the basic difference in conductors, semiconductor and insulators. Thank you.